So hello guys, it's me again, Dustin Delejero, BSEE 3B of ISAT University main campus. So hello guys, today we will try to talk about CPU. So what is CPU? CPU, or the Central Processing Unit, is somewhat called as the brain of the computer, where it sits at the center of everything in the computer and handles all the computation needed to turn inputs from memory into outputs on your peripherals. Or in simple terms, it does what we tell or program it to do. So before having these computers like of what we have today, it came first from supercomputers like the ENIAC, or the Electronic Numerical Integrator and Computer, which is said to be the first general-purpose digital computer from 1946, where it covered about 1,800 square feet and weighed about 30 tons. And according to history, other earlier computers were made using vacuum tube technology that makes them gigantic and undependable, which programming them was complicated and error-prone. Not until John von Neumann produced a new kind of computer architecture that simplified design and programming in the late 1940s. This time, he introduced this four-step instruction cycle, namely the fetch, decode, execute, and write back, where this architecture was revolutionary that modern computers are still today based on these basic principles. And in the 1950s, semiconductor-based transistors started to hit the market, replacing the larger, more unreliable mechanical vacuum tube-based technologies. This brought smaller and faster circuits to the electronics industry. Then, several years later, when Robert Noyce and Gordon Moore converged, they have founded Intel, which is now one of the most leading processors in the whole wide world, where in 1971, they have unveiled the Intel 4004 single-chip microprocessor for the calculator market. Also, this chip was the first general-purpose programmable processor and said that it contains all of the computational power of the ENIAC into one tiny device. After then, the process of shrinking transistors was made in the industry, thanks to Moore's Law, where it stated that we can double the number of transistors per unit area every 2 years. This law will only tell us that as time goes by, the things that we thought that are impossible will not only be possible, but also be a cheaper one. But the question is, how can we program a processor? So that is through ISA, or Instruction Set Architecture. So ISA is a set of instructions that defines what kind of operation can be performed in the hardware, or what storage mechanisms are used in a processor. This describes memory model, supported data types, registers, and behavior of the machine code. Because of that, ISA is said to be one of the most critical part of modern CPU design, as they are the link between the software and the hardware that permits effective high-performance computation and a flawless software experience across a variety of CPU microarchitectures. So, x86, ARM, and 68K family are some families included to ISA. And as of today, the CPU makes a prediction on what direction the branch might take and begin executing instructions based on that direction. It can often predict branches with a near-perfect accuracy that makes them seem almost clairvoyant. So when a processor executes newer instructions than a branch without knowing if that branch is taken or not, it is referred to as speculative execution. So this is the fundamental component in modern microprocessors for achieving a great performance. Or in simple terms, speculations is like a tour guide that will help you choose the right track to reach your desired directions of success for your CPU. So that would be all, guys. Thank you. Special thanks to the following: